Okay, we're back in section 7.5. This is going to be the second and last part of the video. This will also be a pretty lengthy portion because of the work involved in doing some of the questions. So we need to first review a property involving negative exponents. So this will be just kind of a review of work that you should have done in Math 95. I don't think it warrants, or Math 90 I should say, I don't think it warrants that we necessarily do a whole section review on this, but let's go ahead and take a look at what this property entails. So if we have something written as x to the negative 1, well, one property that I need to be aware of, I can rewrite this so that it contains a positive exponent if I put a 1 under this. To get rid of the negative exponent, which is a piece of what we're going to need to do here, I can go ahead and write this as 1 over x, which would be 1 over x to the 1. So taking a look at another example, if I have p to the negative 3, if I go ahead and put a 1 under that, I can write that as 1 over p to the third. The long story short, if I want to get rid of the negative exponent, I basically need to make the expression into a fraction and then take the reciprocal of it. This will get rid of the negative exponent. So we're going to see a couple problems that we're going to do that are going to utilize this property, and I just want everyone to be ready for that. So let's go ahead and take a look at question number 21. So this is going to be x to the minus 1 plus y to the minus 1 divided by the quantity of x squared minus y squared over xy. So when you first look at the numerator of the complex fraction, and by numerator I mean x to the negative 1 plus y to the negative 1, it would appear that there's no fractions. So we need to rewrite x to the negative 1 and y to the negative 1 so we get rid of the negative exponents. Well, the way we do that, like in the review I just showed you, is we're going to go ahead and write x to the negative 1 as 1 over x. I'm going to go ahead and write y to the negative 1 as 1 over y. And again, we'll bring the rest of this here with. Is going to be x to the second minus y to the second over x, y. At this point of the question, this is not much different than what we looked at earlier. So the main focus of the next couple activities is how do we get rid of the negative exponent? From here, the rest of the problem is like we saw in the first video. We need to take a look at the denominators in both parts of the complex rational expression and determine what the least common multiple is, which in this case is going to simply be xy. I'm going to go ahead and write this part again and show how this distribution is going to take place. So we're going to have 1 over x plus 1 over y over x squared minus y squared over xy. And I'm going to distribute this x, y over 1 through here, and then x times y over 1 through here. Now, this is the first time I'm going to do this without actually showing all of the distribution work. I've shown plenty of examples of it. If you need further assistance with this in class, don't be afraid to ask. But in the bottom, this simplifies quite nicely by simply reducing the x and y, leaving me with a quantity of x squared minus y squared here. However, let's just take a look at the first part. So here's a little technique that you can use. I'm going to cover up the essential parts here, and let's see what happens. So if I have x, y over 1 times 1 over x, the x's are going to get reduced, leaving me with just y, and y minus times 1 is just y, so the first part is going to be simply y. Now, I'm distributing this. If I have x, y over 1 times 1 over y, the y's would reduce, leaving me with simply, because there's a plus sign here, plus x. Y's reduce, the x remains. So now I have the expression y plus x over x squared minus y squared. Can I do some factoring to simplify this further? Yes, I can. So this is going to be y plus x over x plus y times x minus y. Now, for some students who have taken advantage of a property that we discussed in class, where we have a minus b over b minus a being equal to negative 1, well, y plus x and x plus y, these are the same things. 2 plus 4 and 4 plus 2 are both equal to 6. So if you have these flipped but everything is positive, these simply reduce to 1. So don't put a -1 in this type of cancellation, because here we're adding the two quantities together. They're both positive. So this is going to give us 1 over the quantity of x minus y. So this problem started out with negative exponents. We had to make them into fractions to get rid of those negative exponents, and we had to simplify these much like we did in earlier work. Let's go ahead and take a look at question 29. So in 29, we have something that starts off looking pretty simple, and that's going to be y plus y to the -1 over y minus y to the -1. So this work itself is not complicated, and it's fairly consistent in the technique, but there are little things that you have to be aware of and little techniques to help simplify, and hopefully these videos will expose you to these techniques. So what I need to do in each part of here is I need to do a little work with this and with that. So I'm going to go ahead and rewrite this as y plus 1 over y to get rid of the negative exponent on here. And this is going to be identical, except it's going to be y minus 1 over y. So as I look at this, the only denominators I have in here and here are y. So the least common denominator for all this is going to be y. So I'm going to multiply all this through by y over 1 and by y over 1. So let's go ahead and carry out this distribution now. Y times y, if it helps, put a 1 there. Y times y, and this doesn't reduce at all, that's going to give me y to the second. Y over 1 times 1 over y. Here the y is reduced to nothing, and that's just going to be y squared plus 1. Over here, let's put a 1 under the y. Y over 1 times y over 1, well, that's y squared. If I multiply y over 1 times 1 over y is reduced, simply leaving me with y squared minus 1. Now, you can look at this and you may say, but this can be factored. It's true. We can factor y squared minus 1 to y plus 1 times y minus 1. But the numerator of this is not factorable. Y squared plus 1 is not factorable because we cannot factor the sum of perfect squares. And by factoring y squared minus 1, it won't get anything here that will reduce to the top. So you could factor this and rewrite your answer as y squared plus 1 over y plus 1 y minus 1. But it is not necessary. You need not do any further work than what is done here. So again, the focus of this is how you handle negative exponents in simplifying complex rational expressions, and that typically works by converting them to fractions. Let's go ahead and take a look at a few more complex problems, and we'll take a look now at 41. So, and this problem is going to be a pretty big one. Well, we'll see if you can squeeze it on this paper here. I'm going to make a big line for it. So this is going to be 2 times the quantity of a squared minus 1 plus 1 over the quantity of a plus 1 divided by the quantity of 3 over a squared minus 1 plus 2 over a minus 1. So as you're looking at this at first, you may ask, is it possible to do any simplification in the numerator of the complex fraction and doing simplification in the denominator of the complex rational expression? And yes, there is. So we're going to take a look at each part one at a time and try to simplify that. So one technique you're going to hear me use is not trying to do too much work around the problem all the time, especially when we have some factoring to do and then having to multiply fractions. It's sometimes easier to take this work to the side, simplify it, and then reincorporate it into the next step of the problem. So that's what we're going to do. So I'm going to take this here again, but I'm going to write this in the factored form. So 2 over a squared minus 1, I can write as 2 over a plus 1 times a minus 1. This is the difference of perfect squares, plus 1 over a plus 1. So I should recognize here that if I want to try to do a little consolidation, that these have a common factor of a plus 1, but I need a plus 1, but I need an a minus 1. So I'm going to go ahead and multiply the top and bottom of this fraction by a minus 1 to help get a common denominator so I can simplify this a little bit. So when I do that, that's going to give me 2 plus 1 times a minus 1 over a plus 1 times a minus 1. And when I multiply that through, that's going to give me 2 plus a minus 1 over a plus 1 times a minus 1. Now I have 2, I have negative 1, 2 minus 1, that's going to give me a plus 1 over a plus 1 times a minus 1. I'm really thorough about my steps. I can reduce the a plus 1s and be left with 1 on top, so that'll give me 1 over a minus 1. So this entire top piece here is going to simplify to 1 over a minus 1 when I do all the work that I've shown here. If we now try to simplify the bottom part of this fraction a little bit here, which I will show below, and I think we'll have enough room to reasonably show that. I'm just going to move this up a little bit though. I'm going to go ahead and write this part in factored form. So now I have 3 over a plus 1 times a minus 1 plus 2 over a minus 1. I see here that I have a minus 1 as a common factor. Note the work that we did in section 7.4. It's now going to come in handy for the work we're now doing in section 7.5. So I realize I have a minus 1 as a common factor, but this one has an a plus 1 I don't have here. So I'm going to go ahead and multiply the bottom in top by a plus 1. So as I do that now, I can go ahead and write this equal. So I can write this as one fraction now as 3 plus 2 times a plus 1 over a plus 1 times a minus 1. Now I can't reduce the a minus 1s because we have 3 plus 2 times a minus 1. I can't reduce it. We have this joined with the 3 here. I need to see what I can do to simplify this a little bit. Maybe we can, but not in the form it's in. So this will be 3 plus 2 times a is 2a. Then 2 plus 2, or 2 times 1 is plus 2. And this will be over a plus 1 times a minus 1. So as I simplify this is going to be 2a plus 5 over a plus 1 times a minus 1. So down here I'm going to have 2a plus 5 over a plus 1 times a minus 1. So as we look at this now, I'm going to need to get rid of the denominator here and here. So what am I going to multiply the top and bottom by, or the top by in both these cases? By what's the least common factors of these, the least common multiples of these, which is going to be a plus 1 times a minus 1 over 1, and a plus 1 times a minus 1 over 1. So in the top, this cleans up pretty nicely by crossing out a minus 1 and leaving me with a plus 1. In the top, both of these will reduce, leaving me with 2a plus 5. And now we have an answer for question number 29 that is in, or excuse me, for question number 41 that is in simplest form as a plus 1 over 2a plus 5. Take time to look at the work involved in these. Yes, these problems do get complex. We're going to do 2 more problems to close off the lesson in section 7.5, and questions 47 and question 49. Going to question 47 now. A bit of a different take, and there are a lot of different little tricks for these problems. You will probably need to come back to this video again and again to see what these little tricks are to help refresh your memory. So here we've got the quantity of t plus 5 plus 3 over, not 2, 3 over t divided by the quantity of t plus 2 plus 1 over t. So, again, we're looking at the numerator of the complex rational expression and the denominator of the complex rational expression to see if there are any fractions in each of those. And yeah, we have a t here and a t here. So all that means is we're going to multiply the top and the bottom through by t. Now, you could write it as t over 1 if you wanted to be consistent, but it might be a little easier for some of you to see it as just t. And let's go ahead and distribute it. T times t is t to the second. T times 5 is plus 5t. And then we have t times 3 divided by t. These t's reduce, giving us just 3. T times t down here is t to the second. T times 2 is going to be plus 2t. And then t times 1 over t. The t's reduce here, giving us just t squared plus 2t plus 1. So for question 47, you could try to factor this because you would get t plus 1 times t plus 1. However, in the case of the numerator can't be factored at all. This is a prime. This would give you, at least now with real numbers. So this is as simple as we can express this answer in simplest form. But the trick with this is just to see that if you have a t here and a t here in the denominators of both parts of this rational expression, you need to multiply through by t. Taking a look at one more question with a similar flavor will be question 49. And that's going to be x minus 2 minus 1 over x divided by the quantity of x minus 5 minus 4 over x. Now, let's see what happens with this question, and let's see where it's going to go. So, again, like the question above, we have x and x here in the denominators, so we're going to go ahead and multiply through by x and x here. X times x is going to be equal to x squared. X times negative 2 is going to be negative 2x. X times negative 1 over x, the x is reduced, leaving us with negative 1. X times x is going to be x squared. X times negative 5 is going to be negative 5x. Then x times negative 4 over x, the x is reduced, leaving us with x squared minus 5x minus 4. Again, you can try to factor these. Actually, neither of these factor. Watch your signs. You may think they do. But this is in simplest form. But always watch out for the factoring that may or may not be able to take place when you do this type of work, as that would be a natural one to look for. This wraps up our lesson in section 7.5. Please refer to these again and again as you try some of the questions in your homework. I think you will find these tips to be very helpful. They may be different than the types of tips that you're provided with in my math lab, so don't be shy about coming back to these videos in the future. Just make sure you watch it at least once by the time it's due. Thank you.